Hey guys, these are our last little set of notes. There's really not much here, just a couple of new or different ways I can ask problems about the binomial theorem. So first I thought I would just do this expansion just so we have one more example of that. So again, we got to remember for each of these, there's three pieces: coefficient, power of the first thing, power of the second thing. First thing here is 2x, the second thing is -1. I address the negative by just changing the sign on every other term to negative. If you want to use -1 as your second thing, you can, but that to me is more confusing. So this is the 7 is the power. So I know that these first numbers are going to be 7c and then another number, and it starts at 0, and that goes all the way up to that'll go all the way up to 7. So 7 choose 0, and then the first thing to the 7th power, and then the second thing to the 0th power. Conveniently for this one, these ones are all just going to be 1. It doesn't matter what power I raise it to, so I don't have to worry about that. Now I got to put a minus here because I got to alternate signs because of the negative. So I'm going to have 7 choose 1 times 2x to the 6th times 1 to the 1 plus 7 choose 2 times 2x to the 5th times 1 squared. I'm writing the ones here. Like I said before, I don't actually have to write them. But to me, there's like there's something to be said for noticing that the powers on the second thing and the second number here are always the same. So it just kind of helps me keep track. These two numbers always add up to 7. I mean, that was the original power. That's always just a good thing to kind of keep track of. So positive, negative, plus 7 choose 4 times 2x cubed times 1 to the 4th minus 7 choose 5 times 2x squared times 1 to the 5th plus 7 choose 6 times 2x to the 1st times 1 to the 6th plus 7 choose 7 times 2x to the 0 times 1 to the 7th. And now we simplify. 7 choose 0 is 1, and 2x to the 7th. 2 to the 7th is 128, I believe. 128x to the 7th times 1 is just 1. Minus 7 choose 1 is 7. 2 to the 6th is 64. Plus, now 7 choose 2, that one I don't know off the top of my head. But I can do it in my calculator. Do the old math. 0. It's not 0. Go over the probability. And 7 choose 2 is 21. So this was minus plus 21 times 2 to the 5th is 32. X to the 5th minus 7 choose 3, which is 35, times 2x to the 4th is 16, x to the 4th, plus 7 choose 4 is the same as 7 choose 5. So it's, sorry, 7 choose 3, so it's 35 times 2x cubed is 8x cubed. Minus 7 choose 5 is the same as 7 choose 2, which was 21. 4x squared times 1 to the 5th. 7 choose 6 is the same as 7 choose 1, which was 7 times 2x, and then 7 choose 7 is 1. And everything in this last term, that's a 1, that's a 1, that's a 1, so there's a 1 here. And now the last step is just to combine all my coefficients so that this looks a little more like a math problem. 7 times 64 is 448. 21 times 32, 672. 35 times 16 is 560. 35 times 8 is 280. 84x squared. 7 times 2x is 14x plus 1. Somewhere I missed a sign. Plus, minus, plus, minus, plus, minus, plus. That last one should have been negative. That's my mistake. Minus. Minus 1. So there's a kind of a, that's a pretty long one. 7th power has 8 terms in it. 1, 2, 3, 4, 5, 6, 7, 8. This one was made a little easier because of the 1, but this is about as big as I could expect you to do. Remember that I find these binomial coefficients by using my calculator. Maybe you heard me say a couple of times, something like 7 choose 2 is the same as 7 choose 5, which is true. If you can figure out that pattern, then it makes, you only have to do basically half of these, and then the rest of them are going to be the same. So I'm actually going to stop this here, and I'll do the other examples in the next video.